Okay,
So
so
Bruce,
recording
yeah,
started for today. As you can see, I don't have a video, but that should be all right because Gary has a video. Bruce should be joining us anytime. We had some problem with the system, so we set up another group, but apparently that group wasn't working, so we just sort of switch to a new group, and Bruce is going to join us pretty quickly, I guess. So, first of all, I think all of you have seen your test papers. Have you seen your test paper, Gary?
yes, I have. Yes.
Okay. So, what I have done for test papers, I make it available for you, so you should be able to actually go over your test paper and see your mark and also see my marking. So if you got any problem, just send me an email and let me know.
Yep. No, cool. Thank you.
Okay, but anyway, generally it was okay. I'm actually quite happy with the test result. It was way better in house students, so it's looked like
Y-
that you guys working very hard. Good job.
Yeah, I mean, there's still a few like the fault calculations. I sort of kept the methodology, but I got I didn't do something at the start, but because I kept it all going, it sort of just fed on, use those same results to get to the rest of it. But yeah,
Yeah,
I sort of
I mean,
yeah
it was good actually. Yeah, it wasn't that bad. Because what happening, I mean, fault calculation also is something straightforward. If you just know how to deal with that, then you can solve it. So it's just a matter of getting it the first time, then you know how to do any of this fault calculations. But I think you are all right. You did very well actually.
yeah. Some of it just I just try to remember I remember reading that somewhere, and the cow one we talked about the TT system. We talked about that in class, so I just used that example in my, my answers.
Anyway, you don't need to get 100%, right?
No,
To be
I was
to
happy
be
with
honest,
well.
yeah,
I
I'm pretty
knuckled down
sure.
and got some study done this time. So
Yeah, I'm pretty sure if I set the test, I'm not going to get 100%. There is only one person that can get 100%, and you know him.
yeah.
He's a special.
Seems to be once he sees it, it seems to stick in his head.
Yeah, that's right. Okay, so the other thing is around practical reports. I haven't yet marked them. The reason I haven't yet started marking them was that I got some of this by email, so I uploaded them myself. Now I got everybody's everybody's work except Aaron. That anyway, he been in touch with me. I know the problem, but but other
Yeah,
guys, I wanted you to actually check that before that. So maybe just have a look at your submission for today and tomorrow, and if I just haven't heard back from you, that means that you are happy with your submission, and I just go and I mark your practical report. But
yeah,
overall, I quite like them actually. They are very detailed mostly and explain very well, but obviously I haven't yet looked at them the way that I mark things. All good?
yep.
Okay. Now, what else left from power system? Actually, not much. So we have covered fault calculation, we covered analysis, looking at different problems, and even in the practical activities that we did, we actually covered protection and we covered working on fuses and things like that. But anyway, as I promised, we're going over fault calculation, we gone over that, and we're going over sort of fuses and circuit breakers, and also protection. These two topics are not very heavy. They're kind of wordy, and uh, sort of a little bit of learning requires over there. So first of all, if you're looking at, so we're looking at basically, um, oh, look at the rain. Are you hearing the sound? The sound of rain? It is raining heavily here in Hamilton.
No, no, it doesn't rain in Hamilton, does it?
Yeah, it's actually raining very badly. I was planning to go home by walking, but I don't think that it is possible. So
Yeah.
I'm going to call my wife to come and pick me up.
Yeah.
Wow, it's getting worse.
I can't hear it.
That's the first time that we're getting heavy rain like that this year. I don't remember any heavy rain happening before that. Anyway,
No.
so we have switches. Basically, instead of switches, let's say circuit breakers and fuses, sizing them and knowing what they are, and protection and a SCADA. These two things are the only two things that's left over. So today we just go over circuit breakers and fuses. Then next week we're going to cover protection and SCADA pretty quickly. And after that we just left over with one more session. Okay, we're going to have our online test number 2. And after online test number 2, which is going to be from stuff that we haven't covered in test 1 and 2 until pretty much the end. And after that, basically, is revision and the course is finished. So not much things left over.
Have they got an exam date yet?
Yes, we actually scheduled the exam. I think we should have it because all the students receive the exam. To be honest, I don't remember exactly which day was it, but maybe I can find it now. Let me say exam timetable. Exam timetable. Yeah, exam timetable, that's the one. Okay, semester 1, exam timetable draft. Okay, that's good. So we have exam timetable. Welcome, Bruce. Welcome back, Bruce. Sorry for making problem for you and going and coming. But now, anyway, we can record that. Yeah. Exam timetable, it is scheduled on Monday, 27th of June.
Monday, 27th of June.
Yeah, 27th of June from 1 o'clock.
Yep.
Okay, so the way it is working, I actually have 2 places reserved for Bruce and Ethan because I think they would rather to come to Hamilton to sit the exam, but the rest of you are going to do that the same way. Also, the other thing is that also you need to let me know about your supervisor. Are you
Right.
Yeah, and is it going to be the same person or sort of it's going to be a different person? I don't have your sort of video. Have you decided to not to share your video or?
Oh, no, going, sorry, I just,
Yeah, I mean,
there we go.
yeah, it is good having you speaking.
It's all right. No, just even now the kids racing and
No, that's fine. I mean, just the way as you sort of like. But what happening if I see one person here? It is kind of making it easier for me. It's like more real.
talking to yourself.
Yeah, that's good. But what's happening? I just don't have the webcam today.
Yeah.
So you're right. Actually, there is some value in having webcam because it makes some more feeling that you have a real person in front of you rather than just computer talking with you.
I don't know why my screen's not working. I can see you guys, but I can't see you.
Oh, okay. So that's okay anyway.
It might do it. Oh, there we go.
Oh, okay. You are here. Awesome. So
It took about 10 minutes for the email to get to me. I only just got the email.
oh, sorry for that. I actually sent you a personal email as well as the one that I share. So I don't know why it's not working. So I just said about the exam. and it is going to be 27th of June. Yes, scheduled. And also we discussed that, okay, what left the power system is all basically fuses and circuit breakers and fuses, sizing them and knowing how they are, and protection and SCADA. And basically we are only going to have 2 more presentations this way. One of them is this one for circuits and fuses, and protection and SCADA going to be right after, so maybe next week. And after that I'm thinking of having an online test for these 2 topics basically, and then review, and obviously we have the exam, so not much left from power system.
The online test will be in, do you say 2 weeks time on around what dates there?
Right now Darren is away, so I wanted to sort of schedule that the way that Darren come back, so
Yep.
after 3 weeks. Are you guys okay with that?
Yep.
Yeah, so that's
Yep, just trying to.
yeah, he comes back
Yep.
and also he can attend that, because he said that he has a limited access to internet at work. So yeah, I guess.
Yeah. He's away, working away at the moment, I think.
That's right. So circuit breaker and fuses, we actually don't have much things in this stuff, because lots of that is sort of reading rather than actually, I mean, something that requires a lot of my explanation. Circuits and fuses. So for circuit breakers and for fuses, first of all, what's the difference between a fuse and a circuit breaker in terms of operation? Can any of you guys tell me?
Fuse only works once and then it's stuffed. A circuit breaker can be reset.
Yes. What else?
I guess a circuit breaker has electromechanical tripping, and thermal tripping, whereas a fuse is only thermal tripping.
That's correct as well. And one more change. Fuse doesn't need a relay to operate.
Oh, yeah.
The fuse is detecting the problem, processing this, and making the action. So fuse, unlike, for example, relay and circuit breaker, if you look at that, so fuse is actually doing everything by itself. So I think all of you guys are familiar with fuses, so it's not much to say about that, but just a symbol to remember. So we have basically 3 different symbols, but that symbol is the IEEE American symbol, but these 2 symbols are IEC symbols, so you may see any of them. And to rate fuses, we need to know about IN, nominal current, and also speed. Speed is important because if it is a motor, you require you need to live it more time comparing to the situation that is like lighting. So we have GG fuses for general use and GM fuses for motors, which is like a slow motors. We have also I2T value. It is about the time that takes to melt the fuse. So it is, or any of the fuses have a specific value. They require basically a specific energy to melt down, and that energy can be achieved by increasing the current or giving it more time. Okay, so basically these 3 things make you can decide the fuse rating. For breaking capacity, we have different types of fuses. One of these fuses that we use a lot more often these days is HRC fuses, high rupturing fuse, high rupturing capacity, or high rupture capacity. Obviously, rated voltage need to be considered. Voltage drop, not that much, but yeah, temperature, and sort of we have different things. And I guess you are actually familiar with different ratings that we have for fuses. That's pretty much the same rating for cables. So like, for example, for cables, you can find cables to handle, for example, 21.5 amp, but you sort of need to find a specific rating for that. And that's about the wire, the thickness of the wire, that how the thickness of wire, how the wire is thicker. We have different fuses for different situation. So like this is comparing fuses and circuit breaker, high voltage fuses, how they look like, and fuse holders and things like that. So I think it's straightforward, isn't it?
And high voltage, you'll have, so in distribution, have you got circuit breakers as well as fuses, or is there either one or the other, or circuit breakers just in distribution?
That's something in protection that you need to decide really. Sometimes you need a back off for your fuse or for your switch. So you have your switch as the main protection and you have a fuse if that doesn't work, or the other way. Or you have a sub-circuit, protection of a sub-circuit with fuses, for example, or with switches, and then protection of the higher circuit. That's basically a scenario that you need to choose once you doing the rating for your protection system. But you definitely, actually, you don't need to select a fuse, you don't need to select a circuit breaker. It's basically deciding that based on your fault level and based on also the time that you wanted to interrupt it one, which one works better for you.
Okay.
But if you choose to use a fuse, then obviously you need to consider a lot of things. And all fuses, guys, if you actually search internet, you can find that. And I wanted you guys to do that. All fuses, so like for example, like any circuit breakers, fuses also, they all have manuals. So if we go for any of those fuses, most likely most of them are for a specific vendors. So, but they all are the same thing, and I don't want to really advertise a specific sort of brand here, but if you just go to one of their manuals, so like this one, you can see different types and you can see how they work. Oh, okay, it looks like that this one is not a fuse. Okay, let me be more specific. So not just fuse, HRC fuse manual. And okay, we have this electronic for you. This is for medium voltage. Okay, this is called ABB. So let's have a look at the ABB, the manual provided by ABB, and get some idea. This website, it always provides good information for all courses, for all electrical courses, but the information usually are not in depth, but like primary information is all right. Okay, let me see if the ABB is, oh, okay, it's coming up. Yes, it's downloaded into my computer. Okay, so now they have this fuse. Can you see this fuse here?
Yeah.
And as you can see, a number is given to that, and sort of the type of value, how much it can handle, how much current it can handle for different rating. It is there. It's a sort of high rupturing capacity, short circuit current limited. low rated minimum circuit breakers, so I minimum, and then low switch over voltage UM, and some value explained here that is specific to this, but mostly are standard, so most vendors are using the same thing, and the voltage and other sort of things explained here. Guys, they're not going to make one manual for every single switch, but instead they're going to make one manual for different types of switches. So they have a general name usually, like for example here BWMW, and after that some other names here, like for example this 7.2, 6.3. So what is that 7.2 means? What is the 3.1? The 3.1 actually means that how much is their I nominal, and 7.2 so it's a little bit bigger.
That must be the voltage, is it? Right, voltage rating.
Minimum, no. The voltage, yeah, it's possibly the voltage, yes. So it means that the maximum voltage allowed. So you can sort of, yes, it is written here, kilovolt, the nominal voltage that you can use this. So for this 7.2, and then the minimum current that can be interrupted at 6 amp, and UM switching voltage, that's a switching, and sort of other numbers that we have here, and then for 12 kilovolt, for 24, for 33, 36 kilovolt also, this value is given to us, and here there is another table here. This is sort of another specification. I nominal given to us, and the frequency that it can operate, which is for New Zealand and America, it works. And here the weight. So it's more sort of information about weight and installation. Here how it is look like. Here about the size. And some other information about the link, how they look like. And then transformer rated power, where to use them if it is with a transformer. Here also some other information to be used with rating to get to know that how quick they tripping, and I switching, I phaser, sorry, fusing, how much is I fusing. And here we have a curve. I wanted you guys to also have an understanding of this curve. I guess you all have done that once you were doing protections, because it's pretty much the same thing, the same concept. It's not making much difference. So as you can see, this here is logarithmic. Oh, we have two Gary here. How come?
Yeah. I'm just getting rid of one because not very good reception. My internet's not.
That's not a problem. So we can have as many as Gary that you want. Okay. So as you can see, the reference is logarithmic. So time in one side, and another side we have current. But looking at this, it's kiloamp. Okay, and obviously for different value, different numbers, for different sizing, so all of them are here. So what we need to, if we wanted to use this, how we can use this? One, we need to make sure that the rating is working for our situation. So we need to make sure that, for example, if our current is 10 amp, actually, if you look at this, you can see that it is not going to interrupt 10 amp. But if your current is 10 amp, more than 10 amp, you never ever should use this fuse. Why is that? Because this fuse is only showing up to a specific value. So that a specific value that you can see in this picture is limited to just normal operation of the fuse. But if you're using, for example, if your nominal current is like 10 amp, you should make sure that you're using at least the 10 amp fuse. But actually, even if you look at this, you can see that this one is also not going to cross 10 amp. Why is that? Because it's just one section of the curve. It's not meant to show that. And here only it is showing 100 second, okay? The first 100 second that we require for protection. Obviously, if you leave it for a long time, the system gonna be, your current going to be interrupted. Make sense, guys? So yes, first thing is the nominal current. You should make sure the nominal current is all right. And the second thing that you need to also make sure it is correct is that the overload that you want, if you have an overload in your system, if you use it for a transformer or something like that, the overload or the inrush current for the period that it is happening, this is the period that it is happening, you let that to go. So you're not making any problem for that. Is that making sense to you? So we have curves here.
So it was that graph that was above that one, was it
Oh, okay, actually that one is not what I wanted to say. That one is something else. That one was a current, sort of current cutoff characteristic for this, but that's the one that I mean too, which is time versus voltage, time versus current.
all right, yeah.
Time versus current. So just the reference is logarithmic. That's the important thing to consider.
So the current down the bottom is what? So you got the current, the duration of the fuse at the top, time on the side, and then you got your current on the bottom.
Current on the bottom, yes, exactly. T in the side here, time second.
Yeah.
And here you have current amp.
Yeah. Okay.
Makes sense?
Is it like the instantaneous current it can handle? Is it what you're saying?
Instantaneous, actually nothing is instantaneous.
No.
Actually, if you're talking about fuse, because it takes some time to melt down.
Yes.
The link. So yeah.
Okay.
What I mean here, I mean, it is not showing the whole picture. So, for example, if you look at this fuse, 6.3 amp, 6.3 amp is actually not cutting 10 amp here, okay? But if you look further, it is going to cut that. So don't just look at this curve and say it is all right, because it is not all right. It is just showing that in first 1000 seconds, if you have 10 amp, the fuse is going to tolerate that. So the nominal current, definitely you need to make sure that the nominal current is below the value of the fuse, okay?
Yep.
And also you need to make sure that if you have inrush current, the inrush current can be handled. Okay?
Sorry, that's what I meant, inrush current, sorry. Yep.
Yeah, exactly. So we have different fuses, different types, so you can see that we have different curves for different fuses and some other information. Are you guys all right with that?
Yep.
Yep.
So yeah, I guess it is good to look at this sort of ABB things. We may have a question like, for example, size this specific fuse for this given situation. So I think you should be fine with that kind of things. Okay, that's about fuses. Now about circuit breakers. For circuit breakers, we have different types of circuit breakers. That's just MCB. So this one is for small applications, for like applications that we don't require a lot of current. And for this circuit breakers anyway, that circuit breaker that I will show you, these things are the symbols, standard symbols for circuit breakers. Can you see that? So in electrical drawings, you may have circuit breakers like that, and that means that actually it is draw out. So that's a circuit breaker I discussed before. So how it works, you basically can move the circuit breaker out, so you don't need a disconnect. You can just use this as a circuit breaker. This is a circuit breaker non-draw out. So that's actually, that box is a sign for having a circuit breaker. This is molded case circuit breaker. So molded case circuit breaker is like that. And then this is molded case circuit breaker, where you have that one is with draw out. So that's sort of this top and bottom is where you have draw out, and this means that you don't have a draw out. So all of them are circuit breakers, but for different situations. In electrical drawings, there is nothing showing that the circuit breaker is SF6 circuit breaker, or it is oil circuit breaker or something like that. Why is that? Because electrical drawing doesn't care about that. All it cares is that we have a circuit breaker, and that's a type of circuit breaker, and that's how you can disconnect it. But obviously, this is something else that we need to look at it. Make sense?
Yep.
Okay. How they look like? We have this circuit breakers. Obviously, like miniature circuit breakers. These circuit breakers are just a standard. We use them in domestic situation, or that one. So that's for mainly low voltage and low current situation. And we have bigger circuit breakers like this as well. So I wanted you guys to actually go over some of this stuff, go over this, and you read it yourself. So for circuit breakers, for low voltage circuit breakers, we basically have MCB and we have MCCB. So what is MCCB stands for?
Molded case.
Molded case circuit breakers. And we have low voltage circuit breakers. But for high voltage, so let me write them here. So for circuit breakers, so fuses, we said about that. And for circuit breaker, it is low voltage. We have MCB. MCB is like for up to, usually up to 100 amp, in some cases 120, and usually it is not adjustable. And this MCB, usually we use that, where we use that, guys, MCB?
Domestic stuff.
Yeah. Domestic, or also, yeah, domestic, or for situation that it's like the last end circuits, sort of. I mean, you can use it for industry as well, but for direct protection, basically. Direct protection, use that because it's not adjustable. You don't need to sort of make sure that it is working with another, it is sort of talking with another one, or it is waiting for another system. The other one that we have is MCCB, molded case circuit breaker, and that's higher rating. But this MCB and MCCB, both of them can basically do the interruption themselves. So it's a little bit adjustable. Some adjustability, and that's not for direct protection. That's for which situation? That's
A relay high voltage.
no. That's for backup protection. And also we have low voltage circuit breaker. Low voltage circuit breaker for higher rating, and also requires a relay to operate. But guys, low voltage circuit breaker is not capable of finding the faults. So it requires a relay to order that. Make sense? So I guess anyway, this is some mainly general information for you guys. But for high voltage, or better to just say circuit breakers, for circuit breakers, they all kind of work in the same way, but they're different because they have different mechanism for arc interruption. Why is that? Because once you have a lot of current, then you need to have an arc mechanism to sort of solve the problem. For circuits, guys, for all sort of circuit breakers, we have an area, basically. We have a discussion that in which situation they are capable of instantaneous circuit breaker. Actually, this is more for MCB, so we end up with these zones. But looking at type of circuit breakers, we have this different types. That's just about MCBs, usually less than 1000 volt AC. So we have type B, type C, and type D. Which one we use more in domestic situation? Have you guys seen that? That's
just type B, wouldn't it?
3 to 5 and 10 to. What you can do, you can just search MCB and you can look at one MCB. Okay, let's just go to the picture of that. And if you look at, for example, this MCB, you can see some of the things written on that. And actually, type is one of those things. So it's not very difficult to work at that. What is the type? Look at this B40. That B is what?
Is the rating type 3 amps up to 5 amp times.
C16. So that C or that B means that actually the type. And here, for example, it is C16, means the type C. Or here, if you look at that, B16. So what's happening? Usually people just go and select them, but that's not enough. Why it is not enough? Because you also, once you wanted to choose a circuit breaker, you also need to work out that which type of circuit breaker works for your situation. So as you can see, we have different types, and this MCB is not adjustable. And once you wanted to just select that based on this standard, British standard 7671, you need to make sure that you are using the right type. In New Zealand, mostly people use type C, but sometimes you may need to use other types. I leave you guys to read these things yourself. So it's showing that how it works. So basically, all circuit breakers, including MCB circuit breakers, the way they're working, they have one adjustable They have one fixed contact and one variable contact, and either using magnetic or thermal, they have a process that the movable contact is moving. So the magnetic things and the thermal circuit, they all are here. So medium voltage circuit breakers, we have different types of we have different types of circuit breakers. We have vacuum circuit breakers, air circuit breakers, SF6 circuit breakers. And for high voltage, we have bulk oil, minimum oil, air blast, vacuum, SFC, and CO2 circuit breakers. So what is this name means? That's actually a way that you are interrupting the currents. Guys, believe it or not, for many years, we used to use water to interrupt the arc. Water circuit breaker or jet water circuit breaker. But anyway, that's not useful these days. For medium voltage circuit breaker. Anyway, looking at this, air circuit breaker rated up to 6,300 amp. And you need to do some activities anyway. SF6 circuit breaker, sulfur hexafluoride circuit breaker is one of the things that actually have been used a lot these days. And we have vacuum circuit breaker. Vacuum, basically, we have a vacuum chamber and the arc is happening in the vacuum chamber. So you just need 6 to 10 millimeter to sort of break that. Air circuit breaker 6 up to 6,300, and also the other one up to 600. And SF6 is having quite a good rating. For high voltage, we have bulk oil, we have minimum oil, air blast, vacuum, SF6, and CO2. CO2 is pretty much similar to SF6. The reason for CO2 is that it is more environmental friendly comparing to SF6, but SF6 is a gas, is very good for cooling as well as for removing the air, as well as, interrupting that, and insulation. And what we have here, we have some video. Just let me to play one of them, how the circuit breaker works. Can you see this video actually, or it's just dark?
Yep, can see it.
Testing, yeah. It's just showing quickly how a circuit breaker works. It's just the arc and the wires, the construction of that, different parts. Different types of that. Okay, that's one video, and others is there. This one is also showing that for bigger things.
Is this a high voltage one then?
Yeah, high voltage one. So you have a chamber, you have different actuators, and you have a magnetic circuit, magnetizing circuit. So look at this. That's your Let me just go back. Operation of that, arc happening. And now you are disconnecting that in the arc chamber. So you're disconnecting that at a point like 0. I mean, you're interrupting that, not disconnecting really. And you make a gap between these two circuits. Okay, anyway, guys, that's all for today. And sizing them is pretty much the same as sizing circuit breakers is pretty much the same as sizing fuses. So nominal current, nominal voltage, and maximum interruption capacity, and also but the breaking time, the difference is that the breaking and how the breaking works goes to the protection. Why is that? Because it requires a relay to receive an order. So circuit breaker is not able to handle that itself. So what is my expectation for you guys to learn? I wanted you to actually learn all this things, circuit breaker, all this page, and study that. And about circuit breakers and different types of circuit breakers, I have some activities and I wanted you guys to go over these activities and do them, because the one that you are doing going to be used, the note that you are going to do going to be used, and I will sort of use them later for sort of for your tests. So here we have one activity, high voltage circuit breakers. So my expectation is that any of you guys pick up one circuit breaker and come here and make a new entry and explain that circuit breaker, all parameters and how to choose that and why to use that, what's the current limit, what's a lifetime, and problems like that. Finding this information is pretty easy. You can just search them on internet. Also, there are some resources available for you in the Moodle that you can find them. Are you guys all right with that?
Yep.
I want you to actually do this. And obviously, I wanted you to go over this page and learn about circuit breakers, MCB circuit breakers, molded case circuit breakers, and also what is the concept of arc interruption, what is the how to select that, and also for MCB, what is this means, different zones, and yeah, things like that, and how the circuit breaker work. And I just want a general understanding of this type of circuit breakers that we have for medium voltage and high voltage situation, which is the resources coming out of your research. Okay?
Yep.
All good, guys?
Okay.
Do you have any question for me?
No, I think I'm pretty good, I think. Can't think of anything.
Okay, good. So how about you, Gary?
Yep, no, all good.
Okay,
Got
so
a reading to do, yeah.
finish the recording, and I am going to send you an email tomorrow. So basically, sort of summarizing the discussion and the reading that we're going to have. All good?
Yep.
Okay. Have a good evening, guys, and see you next week.
Yeah. Okay, thanks.
Bye.
Bye.
Yeah.